Hello everybody, welcome to the spreadsheet that we're going to be able to use to simulate energy usage and energy savings at the 4 cottages that we're going to be looking at. This first spreadsheet is focused on Riepma cottage, and through the next few videos we're going to look through ways that you can use this spreadsheet and how we can use it to simulate different projects. This first video is just going to focus on a little bit about what's here. There's a lot here to go through, so just follow along as I point out some of the key features. These gray boxes that you'll find here are things that are important for the simulation, but you're not going to change, and maybe you won't actually pay too much attention to. This is temperature information. What we're simulating in this model is an average winter month here in Holland, Michigan. So think like a January or February, a typical January or February. We're looking at an inside temperature of 65 degrees and an outside temperature of about 31. So again, average January. That 65 degrees may not sound right. As we can see here in this note, that's a design temperature. The actual home is going to be a little bit warmer because there are other things besides our furnace that are actually providing heat, like the people, lights, appliances, etc. Over here in this gray box, we have some data that's being used in our model for convection as well as air properties. This box here that's gray shows our baseline system. So this is the house as it currently stands here today, not what we're simulating the change to be. So this is something that we're going to just be able to reference back to as we start to change some of the values. Okay, as we scroll down, we can see some areas that are white, some areas that are different colors. We can scroll to the right, and again, we see some white areas and some different colors. In general, the white areas are things you should pay attention to and look at, but not necessarily change. For example, this white area here has a lot of information about common building materials, what their R value is, and what we might want to type in if we're making a change. Down here, this section is the simulation of our home. So again, the white is things that we should pay attention to, like the size of the home, the size of doors, windows, etc., but not necessarily change. This pink region, this is pink for pink insulation, like that pink foam board insulation that we've looked at in class. These are values that you're going to change when we want to simulate a change in the insulation value of some area in the house. The salmon color here are things, so this table here, which is salmon color, and this cell here, which is also that salmon color, are things that we are going to look at with regard to the air changes per hour, or air CH. Air changes per hour, that's a really important thing. We're definitely going to have to spend quite a bit of time and thought looking at air changes per hour in terms of weather sealing. A few other things to note. In a number of places, you'll see a little asterisk, like here for air changes per hour, and you'll see ACH nat, or air changes per hour natural. That's an estimate. This is talking about the natural air changes, how much new fresh air is flowing into our system. And we qualify it by the number of times the volume of the space would have changed out in an hour. So this is Riepma cottage. We're estimating that we will change the entire volume of air in the building about 1.7 times every hour. That's how much leakage there is. Now, cold air leaking in is going to be something we have to pay to heat back up. It's also going to be a comfort factor, but we do need some fresh air. So ASHRAE, which is the American Society for Heating and Air Conditioning Engineers, studies these types of things and recommends a minimum air change per hour of 0.35. This can be just from leaks in the exterior of the house, or what would be more typical in modern construction, we would seal the house really well, and then we would control how much fresh air is actually entering into the structure. But definitely we need to have fresh air, but not quite as much as we have currently. This salmon section of the table, this table is estimates for savings that we could achieve for different interventions. So for example, if we added new attic insulation everywhere in all of the attic spaces, and that were spray foam is going to seal all those little gaps and cracks, and we would expect a fairly large 0.25 change in the air changes per hour. If there's currently zero insulation in any of the walls, and we insulate all of those walls, we would expect that to have a fairly significant effect. Caulking and weather sealing, that's kind of going around the whole house, sealing all the gaps and cracks that we can. Typically, it would involve pulling off the trim piece on windows and doors and sealing behind all of that to stop gaps and cracks. Again, and we would expect, again, a fairly significant savings. So here are some different estimates that we have that we can use as we start to look at the changes in air changes per hour. So that's a quick tour of the spreadsheet. We're going to dive into a little bit more how it was set up, what's actually happening inside in the next video. So I'll see you in the next one.